Well, good afternoon, everybody, and welcome to the, as Marko said, first summer weather briefing. My name is Dunja Plačko-Vršnak, and I'm a senior forecaster at the Croatian Meteorological and Hydrological Service. I work in Zagreb, in the capital of Croatia, which is located in the continental part of Croatia. I will mainly talk about the current weather, and after me, Marko will continue with some analysis of past events. Anyway, I would like to remind you on weather last week when part of Europe was under the influence of a huge extended and stationary ridge with very warm and dry air. A ridge stretching from North Africa up to British Isles, and temperature at 850 hectopascal over France and Spain was between 20 and 25 degrees. Well, the heat wave affected France, Spain, Germany, Italy, with the maximum temperature often higher than 30, even higher than 35 degrees, which was more than 10 degrees higher than the climatological average. For example, France and Spain recorded their hottest June temperature on record, and temperature above 40 degrees was measured in southwest France and South Spain. Return to the actual weather, and as usual, I would like to know where you are come from, and please show me on a map, and also put a mark in the table in the left corner of the image. What is your occupation? I mean, are you a forecaster, researcher, trainer, student, or other? Okay. Okay, we are from Europe mainly, and more or less we are forecasters or researchers. Then it is all the people from same interests. Well, okay, thank you very much for that, and now we will continue. Well, the weather condition in Croatia today is under the influence of high or middle air pressure. Frontal system moved further north during the night, and some humid and colder air come to north part of Croatia. We had thunderstorms yesterday during the night. Now in Zagreb we have partly sunny with temperature around 29 degrees, and at the coast, for example, is in Split, it is also noticed here. The temperature, it's sunny, and the temperature is around 30 degrees. And for those who find it interesting, the sea temperature in Dalmatia is around 24 degrees. As Marko mentioned, the weather is in keeping with the season, and today is, just to remind you, summer solstice, the first day of astronomical summer in the North Hemisphere. And on the summer solstice, the day lasts the longest. In Zagreb, for example, we will have approximately 15 hours and 44 minutes of daylight today. Then enjoy. Now, again, I would appreciate your assistance here. This is the satellite image in a water vapor channel, and it is from this morning, from 6th UTC, and please, can you show me the position of the jets? Well, as you know, that water images show us the amount of water vapor in mid and upper troposphere, and high values of humidity and condensed water droplets or ice crystals are represented by a lighter shade of gray or even white color. But while dry zones are shown as black stripes or dark areas. Yes, very good. You noticed the position of the jets, even in the case of not so clear, maybe for somebody. And now I will overlay the isotope at 300 hectopascal, which indicate the position of the jet, which agree with the dark stripes, for example, and also agree with your drawings at the last slide. For example, here is a very nice pronounced dark stripe or dark area even. Well, the second parameter, which is useful in interpretation of the features seen in satellite images, especially in combination with the water vapor, is geopotential height contours at 300 hectopascal. We can see the, for example, upper level low over the Poland. The other one is over the Atlantic and north part of Portugal and west part of Spain. The third one is, for example, over the Russia, and the trough, this one is over the Black Sea. Also, we can notice here that the high gradient is in isolines of geopotential height indicate the strong wind present at the, for example, here, the southern part of this upper level low, or here, for example, in the it is connected also with the front or frontal zone. And okay, we can proceed. Now we can hear here we can notice the third parameter, which is which I overlaid, and this is the potential vorticity at potential vorticity 1.5 units. And if we look at the potential vorticity field, in this field in magenta, we can notice that the area of low, upper level low mean is and its maximum of PV is very well agree with the upper level low. And also the air below upper level low is potentially unstable, which leads to convective cloudiness, and convective development can be very intensive, especially over the sea, and we will see that later in our in this presentation. Now we can look the air mass RGB. We already noticed 3 or even 4 very interesting features. I mean, 3 or 4 upper level low in water vapor image, and this red area is connected with this upper level low or trough, and the most pronounced one is this one over the Central Europe, and this red color is the descending stratospheric air in the center of the upper level lows, and this descending air appears in a red color, and the cold air appears more in this bluish color, which is surrounded that upper level low. Also, we can here notice that red descending air, this red color, and also in the position of the trough and at this part over Atlantic. If we overlay the thermal front parameter, we can notice the frontal zones and cloudiness inside the frontal zones, and which is noticed, for example, this bright whitish color is indicate the high level thick clouds, which is well connected with that frontal zones. We are talking about the unstable weather before, and this is the infrared image and the Cape. We are, well, during the day we are expected convection, and the significant amount of Cape is present over the West Mediterranean, as we can see, and also over the Black Sea. But this part, for example, which is connected with the upper level low, is there's no significant Cape, for example, in this part. But we can look at the air mass RGB just from 11 UTC, I mean during the day. Some convection already start, especially connected with this upper level low over the Central or Europe, or Central or Eastern part of Europe. Also, we have here some indication of convection, and we can see cloudiness and also bright dots here over the Alps, and a lot of convective cloudiness connecting, as I see, to upper level low and leading edge of upper level low here. Even better, we can recognize some convection in this convective storm or severe storm RGB. These yellow dots, for example, are sign of thick ice clouds with ice particles at the top. A lot of convection is going on, and I mean all over Europe. We have it also over Turkey and Black Sea, over northeastern part of Europe, and over the western Mediterranean, and over the Spain and the part of France. And for the end, early in the morning, when Estofex forecast was issued, we were prepared to convective activity and severe weather. And according to this forecast, the severe weather could happen over Europe, and there are also the level 1 even through a spread over western part and even at the eastern Mediterranean. And for the end, in that direction are the warning issue for today from national services, and more or less these warnings were regarding the convective activity, thunderstorms, and high impact weather. And for example, this red part in Italy is for the very hot weather. I hope that you will not experience severe weather and well, this will be all from my side. Briefly say something about the weather condition over Europe during this morning and afternoon. And yeah.
Good, great. Thank you, Dunja, for this. I will just share now my presentation. It will take a moment. Just thank you, Dunja, again for your first part, for the introduction. Actually, you covered also parts of my presentation, so I will be able to go through them a bit faster. So hello everyone, my name is Marko Blašković, and I'll give now the second part of the this summer weather briefing. So last week, as Dunja already mentioned, we had a heat wave in the western parts of Europe. Most of you or all of you know that, and some interesting facts that I found. I don't know if they're facts, but some interesting statements that I found on the internet. Maybe some of you, if you are from France or from Spain, you can comment in the chat box, write something more about it. Basically, in France, on the 16th of June, Saint-Jean-de-Minervois reached 40 degrees centigrade. That's the earliest ever 40 degrees in France. On the right side and above, you have some Twitter posts from Meteo France about the warnings on those days. So the upper left on for the 16th, 17th, and the middle on the right is for the 18th of June 2022. You can see how they announced the warnings for the heat wave oncoming in parts of France over 40 degrees, firstly in the south, then moving to the central parts of the country. In Spain, there were already temperatures up to 43 degrees, especially Andalusia. Of course, the southern part of Spain is quite famous for its heat. And actually, again, one graph from Twitter that I found from EUMet that says that the average daily temperature across Spain, so the average of averages, if I understood it correctly, was on some days up to 8 degrees Celsius higher than normal. So this is probably this one in the middle, this line. And then on the 17th of June, the day when I started to working on this presentation, I assumed that the heat wave would should come to the rest of Central and South Europe in the next days. Now we will see what happened in the next days a bit later. Now we will just see how it behaved and what actually brought this heat to this western part of the continent. Basically, several days before this 16th of June, a high pressure ridge was already over the western part of the continent. We can see it here on the 12th of June, 12 UTC. And we can already see actually quite high temperatures at 850 hectopascals. These are, of course, the model temperatures, not measured, so just keep that in mind. So that they were probably a bit different, but I would assume really close to these values. And actually, as the days progressed, the ridge just did not move from that position, from the western part of the continent, and because of that, and because of the southwesterly flow inside of it, the temperatures rose. In Spain, they actually fluctuated around one value, but in France, if you check these temperatures at the southern portion of France, you can see that they are gradually increasing from day to day. Here we can see we had in Spain 26.1, 28.3, 27.6, 26.7. In France, it rose from something like 18 to 21.6. So these are already quite high temperatures. Also, as Dunja said, so if we add those 15 degrees to this 850 temperature at 850, we can already get in Spain over 40 and in France high 30s. Degrees Celsius, quite good approximation as it is. Of course, it's not perfect because there are a lot of variables here, but still quite a good approximation of the temperature at 2 meters. If we check now also the wind at so basically we have the geopotential height at 500 hectopascals and the wind at 700. We can see how the combined forces of this, I don't want to say cyclone because it came from the southwest of Spain, so maybe some kind of a depression or something from the Atlantic Ocean, and the force of the ridge, they are throwing, let's say, the air from south and actually from North Africa through Spain to central parts of France, and basically bringing hot air, warm air, hot air to those parts of Europe. And actually, yeah, as I said, I was expecting that the wave will go to the east. So basically, something in the central parts of Europe, maybe in the southern parts of Europe. It might cool down a bit because it has to go over some cooler areas. It has to go away from the origin of the heat. But yeah, I assumed it will get over the most part of the Central Europe. But yeah, then I checked, of course, the infrared image and some sign-up data and other material a couple of days later on 19 June. And actually, what I did see is that, yes, indeed, the wave spread to the central parts, and we can see how this combined forces of this now cyclone and this trough have brought this very warm air to the central parts, even northern central parts. But here in the south, the heat was not so intense, I would have to say. And actually, as you can also see on the infrared image, mostly the central parts of Europe are darker in color, meaning that the air and the ground, the air near the ground are much warmer than the air actually down here in the south. And if this is also one thing that I found on the internet. If there is somebody from Germany, you can correct me. Basically, I found that the Cottbus temperature record was broken, the record that stood for 140 or something years. The highest temperature ever recorded 39.2 degrees Celsius on the 19th of June. And also we can actually see quite high temperatures in Poland, 34, 30, 33, central, north Germany, and etc., etc. We can also very nicely see this, let's say, tongue of warm air spreading across from southwestern Europe to central parts and even way there to the east. Now I'll talk a bit about some thunderstorms that happened on those days. I will start with 16 June again. So you have actually seen this slide a couple of slides ago. On the other side of this, well, rather nice weather in the west, although very hot, we had some changing weather in the central parts and the east parts. We had this northwestern flow, and in that flow usually there are some fluctuations, some disturbances happening, and it's not very stable situation for the areas below it. And because of that, on 16th of June, this disturbance, we see this shortwave trough that was going on in this flow caused some convection in the central parts. Basically, we have some wind curving, some wind convergence. We have, because of the high temperatures and the moisture from the previous weeks, we have some moisture, of course, some moist air. Also, the northwestern flow favors lifting the air over the Alps, so this region also gets a lot of cloud development in those situations. So in any case, that day we got some cloud development earlier at 12 UTC, and now we will actually see what happened later on. Here we have just a field of a cape. The cape was not very high, something around 200, 400, 600, maybe up to 800 joules per Kelvin per kilogram in these central parts, but it picked it up quite nicely. So there was some convergence from the changing directions of the wind, and probably the wind lifted this air enough to the LCL, and the cloud development started, and the clouds started using this cape for their development. Now then, if we switch to a couple of hours later, we can see that at 15 UTC we already have quite nice developed storm clouds, and in this day microphysics RGB we can see they are rather orangey, quite actually bright orange, which means, as it is noted here, they have strong updrafts, and where we have strong updrafts we can expect that there are some serious weather going below the clouds. So we have some rain, some showers, strong wind, hail probably, etc., etc. Now, if we switch to the severe storms convection RGB, we can also see, and even better, I would say, these areas of strong updrafts. They are yellowish or very bright orangey, orange color, and basically this cloud here over Slovenia and Croatia, it seems that it was the most active of the ones here present. And actually, I was tracking this cloud in this storm a bit through radars because it was passing near my hometown in North Croatia and actually near Zagreb. And from the news reports and some Twitter posts, I found that in Slovenia, especially in southeast Slovenia, there was some heavy precipitation, flash floods even, and landslides. In Croatia, not as much. It seemed like it was going towards northeastern parts of Croatia, but it switched to a more more northerly flow, and then it went past down to something like central Croatia, to Karlovac region, and there we had some strong winds and some trees fallen in Karlovac city itself. Also, there was some strong precipitation, but at least what I have found or not found, there were no serious threats from the precipitation or hail, actually. Now, one question for you. You can write in the chat box. That will be the best option. So which channel from the two RGBs is important for detecting small particles, for example, in these updrafts? So you can find the chat box in somewhere on your window on the right side, most probably, and you can write some of these channels inside. I will switch the images so you can see which of the channels are in both of the RGBs, and that you can write something in. So which channel is responsible for flashing up these clouds so they are so bright orange or even yellowish in the convection RGB? I'll just open this up, but it seems nobody is answering. Is that such a hard question? I'll wait for 5 more seconds and then we're going forward because we are already quite over the time. But it seems nobody is, sorry for that. It seems nobody wants to answer. Basically, the 3.9 micrometer channel is responsible for that. And as you can see, it is in both of these RGBs. In the microphysics RGB, it is only the reflected part, which is actually the most important for this, because the smaller the ice particles, the more sunlight is reflected from them, especially in this 3.9 band of the electromagnetic spectrum. And also here, as you can see, 3.9 minus 10.8, it simulates the reflected part of the 3.9, and basically the same story applies. Now we switch to the 13th June, a couple of days earlier. And basically the situation is very similar. We have a ridge over the western part of the continent, and some northwesterly flow over the central parts, which is then interrupted by a bit stronger trough and disturbance in the flow, which affected then the central parts and went down to southern parts of Europe. You can see again here Cape over Slovenia and Croatia, northern parts of Italy, eastern France, southern France, and Spain. If we check the Showalter, we can see the low values of Showalter also in these places, so we can expect some activity, convective activity in the afternoon. This is the 12 UTC image. And if we check also the convergence is here in blue. You can also see convergence signals at 12 UTC from, above North Slovenia, Croatia, southern Austria, something above northern Italy, and in Spain. Now, if you remember these places, and if I switch a couple of hours later, you can actually see really nicely how the storms developed on exactly those areas where we had the convergence, the wind, the cape, and actually, and this you can see in this disturbance in the flow, the shortwave trough here in the ridge, and actually quite a stronger one here in the central parts and over Croatia and in the southern parts. Now here we can see that again, probably the strongest cloud of this series is here. This one over Slovenia and Croatia. The top of the cloud went to some 210, 215 kelvins, so that's rather cold. And actually near where I am now and near my hometown, in a place there was some hail. You can actually see on this image. It was not actually just some hail, it was something like 5 centimeters, maybe more, of hail that fell. It was not large, so that's at least a good sign, but it was very abundant, and as you can see, it covered basically the whole area, the whole ground. It looked like winter. And unfortunately, even though there was no structural damage, the agricultural damage is basically 100% at that place where this picture was taken. So basically all crops are destroyed because of the hail and also the flash floods that happened also during this storm and after the storm. So yeah, just one very short topic at the end. This is actually a small case that I posted on Facebook and Twitter a couple of days ago, last week actually. It's about the bora and the moisture boundary that one of my colleagues told me about, that he noticed. So just a short intro about the bora. Bora is a cold, dry wind that blows from the northeast onto the Adriatic region. So basically Croatia, Slovenia, Italy are most affected. Not sure about the southern countries, but I think they are not so affected by it. Generally, it is a gusty wind that during wintertime often reaches speeds of up to 30 meters per second, but also it can go higher. And during summer, it is usually weaker, but still can cause problems in traffic, especially with the tourists that do not know what bora is and often do not often disregard the warnings of it. And during winter, it is dangerous for its strength, but during summer, potentially dangerous for its drying effect on the environment, which means that it basically creates more fuel for the wildfires to spread and actually causes problems when extinguishing said fires, because it spreads the fires even more and more. Basically, of course, during summer, it's not only dangerous for that, it's also dangerous for its strength. And please, if you go on to the coast, to the Adriatic, please do not disregard bora warnings in any time of the year, because if you get stranded at one point with your camper or your motorcycle, you will probably not be able to go anywhere else if you don't want to roll over or, I don't know, fall somehow. Basically what happened is that the convective system passed over the landslide, over the mainland Croatia, and the winds shifted basically on the northern portions of the Adriatic. the northeasterly wind or the bora on the coast started blowing. And as I said, the bora is a rather dry wind. And as we know, in some RGBs, we can actually see the moisture boundary. And that is actually what I was searching for in these images in the night microphysics RGB. And I will now show you this video. It goes from 0 to 6 UTC on 6 June. And you can just watch this northern part of the Adriatic and look for any signs of the boundary. I will roll the video a couple of more times. It's not long, but I think I think the boundary is quite visible, and you can actually see it very nicely here. As the bora starts blowing, it is blowing the moist air towards Italy and to the south. Now one question for you, short question again. Which beam is responsible for the detection of the water vapor? Actually, better to say maybe the moist air or a moisture boundary. Again, you can write in the chat box either red, green, or blue. You can write either the differences or the channel. And I'll just give you a moment or two. Basically, there are four RGBs that are very similar in structure. Only this night microphysical actually has this green component different for another reason. But as I see, there are again very few answers in the chat, and mostly green. That was I think then a trick question for you, but no, it's not, because this is different from the other RGBs. This is not the difference that is seeing the moisture boundary, but the 12.0 minus 10.8. You have that difference also in the ash RGB, 24-hour microphysics RGB, and dust RGB, and it sees really nicely the differences of the lower level moisture because of the subtle differences in absorption or actually emissivity of these channels when the water vapor is present. Basically, as I said, you can see here the moisture boundary, and we can also see here a very small clouds, low clouds appearing on the border when the wind was blowing already towards and near the Italian coast. Now I'll just show you very shortly these red and yellow dots. This is Opatija in the red dot, Zadar in yellow orange dot, and as the bora blew, the environment in Opatija became drier while Zadar became more moist, and we will be able to see this here. You can see how the relative humidity is changing. This is just before 6 UTC, and you can see how this sudden drop of relative humidity is nicely seen because of bora. It is not just because of the temperature rising, because the drop is quite significant, of some 15%. And actually, as the wind blew the moist air towards the south, you can see how in Zadar the moisture, the relative humidity increased actually around 6 o'clock, right at a good moment, as you can also see here in the video. So yeah, that would be all from me as well. Thank you for listening. Sorry for this a bit longer briefing. The next weather briefing will be held by the FMI on 28th of July at 12 UTC. More of that, it will come on the EUMeTrain website. And now if you have some comments, I'll be glad to read them.